But what actually is a radian? Consider an arc of a circle. When the arc of that circle is equal to the radius, so if this length here is 2, this length here is 2, this length here is also 2, or if this length here is 5, this length here is 5, this length here is also 5, or in general, this length here is r, this length here is r, this length here is r, then the angle that is subtended in there is 1 radian. So this angle here is 1 radian. Normally we don't use a unit to represent radians. If we want to be really clear, we either write the word radian or we sometimes use a little c to represent radian, a bit like we might use a degree symbol for degrees. From this point on in the course, whenever you see an angle, it is in radians by default, unless the question specifies it is in degrees. The only way that it will be specified that it's in degrees is because there is a degree symbol after the angle value. But the default from now on is going to be radians. So we need to get used to using radians because that's going to be the most common angle that we're going to be using. 1 radian is a little bit less than 60 degrees. And we can see that if we look at our definition here. This is almost an equilateral triangle. If this length here was r, it would be an equilateral triangle, and that angle would be 60 degrees, but it's a little bit less because we've taken that length and sort of bulged it out a little bit. Actually, it is about 57.3 degrees. But the key conversion that you need to remember is the fact that pi radians is equal to 180 degrees. If you remember that, everything else can be found from there. But there are certain conversions that are worth knowing by heart because they occur commonly. So if pi is equal to 180 degrees, then 2 pi is 360 degrees, pi is 180 degrees, pi by 2 is 90 degrees, pi by 4 is 45 degrees, pi by 6 is 30 degrees, and pi by 3 is 60 degrees. Now these ones come up regularly and, as I said, are very worth knowing. It also enables us to find quick other conversions. For example, by multiplying this one by 3, we get the 3 pi by 2 is equal to 270 degrees. By multiplying this one by 3, we can get 3 pi by 4 is equal to 135 degrees. Multiplying this one by 5, we can get 5 pi by 6 is 150 degrees. Multiplying this one by 2, we can get 2 pi by 3 is equal to 120 degrees. So whilst it's not necessarily to know these ones, by knowing these ones, we can get to these extra ones very quickly. So they are worth recalling and learning by heart. It's also worth knowing how to convert any radian measure into degrees or vice versa. So we can convert any value by, if we have the degree value and we want to go to the radians value, we're going to multiply by pi over 180. And if we're going the other way from radians to degrees, we're going to multiply by 180 divided by pi. Now the way I like to remember this is if we're going into radians, we need to introduce the pi and remove the 180 degrees, and vice versa. If we're going 2 degrees, we need to remove the pi from the radians and introduce the 180 degrees.